In the previous video, we explored the fundamental concepts of semiconductors and their various types. But how do these tiny chips operate themselves inside electronic devices? How do hundreds of videos get saved in the memory? And how are the saved videos played with a single click? When we speak of a semiconductor, we think of a chip smaller than a fingernail. However, in order to load this tiny high-performance chip onto an electronic device without any conflict with the system and with full functional efficiency, there is something we need. That is the semiconductor software. The software we know is an operating system or apps for PCs or smartphones. To fully understand semiconductors, it is important to know what semiconductor software does. For example, we open a brand new micro SD card and load it into a device. The device tells us that the card's storage space is 64 gigabytes. Then, does that mean the new micro SD card is completely empty? The answer is no. Usually, a new micro SD card contains 500,000 lines of code. This amount would fill tens of thousands of A4 sheets. Why do we need this software with such a vast amount of code? Software has the role of a joystick. To save data, we simply click the Save button without worrying about where and how to save it, and we load any data we want with a click. That's what software does. Semiconductor software really serves to benefit SSDs. An SSD is a small, lightweight, and stable memory semiconductor. What does the semiconductor software do for an SSD? An SSD is comprised of three components: the controller that functions like the CPU of a PC, the DRAM that serves the function of cache memory, and the NAND flash for data storage. However, the NAND flash cannot override its data, which means that when you edit data that's been saved on the NAND flash, the edited version is saved in a separate room from the first one. Thus, it ends up accumulating unnecessary data. All you need is the final draft, yet unnecessary garbage also gets stored, so it becomes difficult to use the SSD's storage space efficiently. Hence, when such unnecessary data piles up, the system erases them every once in a while. Through this process, storage space filled with garbage is cleaned. This process is called garbage collection. On the other hand, if data is repeatedly read, written, and erased in the same space, the SSD lifespan can quickly decrease. The wear leveling process that helps utilize storage space evenly prevents this. Because of the job that this semiconductor software does, it is essential to the SSD. Furthermore, the software plays a big role in popularizing and lowering the price of SSDs. The software reduces the possible errors that could have occurred as the expensive but limited SLC improved into MLC, TLC, and QLC. In our previous video, we said the SLC is like living alone in a studio, while QLC is like 4 people sharing it. If someone called from outside, which method would be more accurate? Calling a person from a room of 1 compared to calling one from a room of 4 would be more accurate. Loading data from QLC can cause errors, and the semiconductor software's job is to reduce such inaccuracy. The software also enhances the semiconductor's durability and stability. Like an airbag in a car protects people, the semiconductor software protects data. What matters most in protecting data is temperature. Some SD cards assure their quality between -25 degrees and 85 degrees Celsius. Why do they provide such assurance? This is because NAND flash memory is largely influenced by temperature. It's highly likely that data that was saved in a cold environment cannot be read when you try to read it in a warm environment. This is when the semiconductor software comes in. It remembers the temperature of when the data was saved and read, so that despite there being a difference in temperature, it can make it possible to load the data. Of course, its functions are not limited to SD cards or SSDs, but they are essential in all devices that need semiconductors, such as smartphones and automotives. As the industry advances, semiconductor software is going to hold greater importance. Today, we learned about what controls the performance, lifespan, stability, and security of semiconductors. If this video was helpful to you, stay tuned for our upcoming content.